So, good morning, students. In today's class, we'll try to see the effect of dielectric medium in the capacitance of a parallel plate capacitor. Okay. So far what we have discussed, parallel plate capacitor, inside there is no medium. Okay. So the capacitance is what we have already discussed regarding that. Now the space between the two plates, if we filled up with a dielectric medium. Okay. So regarding dielectric, you had a discussions earlier. What is a dielectric? Whether it is a conductor, insulator, or it is a semiconductor, or it is a different type of material. What is polar dielectric? What is non-polar dielectric? Okay. What is dielectric breakdown? Okay. What is dielectric strength? Okay. You had a discussions on it earlier. Okay, but one thing we know, you had a discussions on dielectric constant also. Okay, so when we go from a vacuum to a medium, electric field reduces. By what factor electric field reduces? That is called as the dielectric constant of that particular medium. For example, if dielectric constant of a medium is 5, then when you go from vacuum to that particular medium, the electric field will get reduced by 5 times. Okay. Right, so let us start with that. This is a parallel plate capacitor, plus Q minus Q. In between there is no medium, and here electric field is what? Sigma by epsilon naught. Let me call it E naught, just to represent vacuum. E naught. E naught is what? Sigma by epsilon naught. Sigma by epsilon naught, or we can write it as Q divided by A epsilon. Okay, sigma is nothing but Q divided by A. This is the electric field when the space between the two plates is vacuum. Okay, if we replace it by a medium, okay, by dielectric medium, okay, having dielectric constant K, this medium having dielectric constant K. So in this space between the two plates, electric field will no longer remain E naught. It will become, instead of E naught, now the new electric field will become E naught by K. Okay, E naught by K. This dielectric constant is also known as a relative permittivity. So here electric field will get reduced E naught by K times. So in that situation, how much it will become? Sigma by K epsilon naught, or we can write it as Q divided by Ka epsilon naught. Okay, or we can call it like this also. This is medium, so this is sigma by epsilon naught. Since this is this is vacuum, so E naught is equal to sigma by epsilon naught. There is a medium, so electric field will become sigma by epsilon medium, and epsilon medium is nothing but epsilon R into epsilon naught. This is relative permittivity. What is relative permittivity? Relative permittivity is nothing but permittivity of medium divided by permittivity of vacuum. We can think about like that also, and this relative permittivity is known as your dielectric constant. So this epsilon R, we can directly replace it by K. So in both situations, we are going to, whether you think it this way or this way, you are going to get the same expression. Okay, so you're going to get the same expressions. So this is the electric field in between the two plates. Then what will happen to the capacitance? In this equation, what was capacitance? C is equal to epsilon naught A divided by B. C naught, let me call it as C naught for vacuum. Just a symbolic difference. And let me call the new capacitance to be C. Then if I think on this particular line, epsilon naught is now replaced by a medium. I can call epsilon medium, area divided by D. And epsilon medium, just now what you have seen, epsilon medium is nothing but K epsilon naught, A divided by D. So this was the initial capacitance when it was vacuum. Now when we have got a medium, capacitance has become K times the initial capacitance. Okay, it has become K times the initial capacitance. Clear? Okay. So we have seen the capacitance enhances, right? So therefore, now the value of K, okay, it will go between 0 to infinity, sorry, 1 to infinity. Okay, it is 1 for vacuum, and for conductors the value of K will become infinite, right? So now let us think about this capacitor. Let me discuss this point very carefully, and you have to see it properly. There is a battery V volt connected across a capacitor of capacitance C. Suppose here capacitance is C naught, plus Q, minus Q. A battery of V volt is there. Okay, so in this situation, what is the capacitance? Epsilon naught A divided by D. And we have seen the potential difference is V volt. Electric field in the region is E naught sigma by epsilon naught. Okay, potential difference is V volt, and the charge on capacitor, charge is equal to Q. Now this particular capacitor, same capacitor, still in contact with the battery, plus, minus, but now I have inserted a dielectric medium having dielectric constant K. अब क्या होगा? What will happen now? बोलो बोलो बोलो, क्या होगा अभी? Sorry. Okay, what will happen here now? What will be the capacitance? We know the new capacitance C will become what? K times C naught. What will happen to the new capacitance? Initial capacitance was C naught epsilon naught A by D. The new capacitance will become K times the initial. What will happen to the potential now? Potential difference initially is how much? V. Now how much will become? K times V? Oh no, sorry, the same battery is connected. Yeah, same battery is connected. We are not changing the battery. Since we are not changing the battery, potential drop across the capacitor cannot change, because potential difference between these 2 points is V. That is, potential drop across the capacitor is what? V. So since the battery is still in contact, the potential difference between the 2 plates will become how much? V. Okay. What will happen to the electric field in the region? What will happen to the electric field in the region? Will it change? Acha, that is a big question. We'll come to that. What will happen to the charge now? Charge. In the previous case, charge was equal to C naught V. Charge was equal to C naught V. Now charge will become C V, because capacitance has become C. Okay. In this situation, what will happen? C is equal to what? K C naught into V. K. What is C naught V? C naught V is nothing but Q. So charge holding capacity of the capacitor has increased by K times in these situations. Right? I have written here sigma E naught is equal to sigma by epsilon naught. What is sigma? Q divided by A epsilon naught. Let us see what will happen to the electric field now in the region. This is this particular situation we are discussing with the battery in contact. Now I'll be discussing one more situation, but after removing the battery. Okay, things will become very clear. Have patience. Now what will be the electric field in the region? Obviously electric field in the region will become sigma by, what is the sigma now? Will it remain the same? Here is Q divided by A epsilon naught. Now I have to write it as what? This is new charge. Let me call it as Q dash. So this new electric field will become Q dash divided by A. This is no longer epsilon naught. This is vacuum, so epsilon naught. Here there is medium, so I'll have to write epsilon M. What is Q dash? Is nothing but KQ. What is area? A. What is epsilon M? K epsilon naught. KK cancels. Q divided by A epsilon naught. Or electric field in between the plates has remained the same. In what situation? Remember, in what situation? When the battery is in contact. We can think this one in a different way. Potential difference is remaining the same. Plate separation is remaining the same. So in this case, potential difference was how much? V volt. Plate separation was how much? D. So what was the electric field? Electric field is V divided by D. In this situation also, potential is remaining the same. Plate separation is remaining the same. So electric field, okay, in this situation also will become V by D. So when the battery is in contact, the potential, the electric field in between the two plates, okay, in the region is going to remain the same. Sir, why same? In the previous case you have said it has increased by K times. Now you are saying same. Okay, this difference you have to understand. Okay, here charge was Q, here charge is no longer Q, but it is K times Q. Charge is increased by K times, that is why electric field has remained the same. If I would have considered the same amount of charge, then you would have seen the electric field has reduced by K times. Anyway, when a medium comes, electric field reduces by K times, we'll understand it. Now you consider the situation, you consider the same situations with the battery. Okay, this part, note it down, I'll rub it off. Now I have removed the battery. So this is the capacitor, fully charged capacitor. What is the charge here? Plus Q. What is the charge here? Minus Q. I have charged the capacitor fully. Now I am removing the battery. Clear? We have charged the capacitor fully. What is the charge? Plus Q. What is the potential difference? V volt. What is the electric field? Sigma by epsilon naught. Now we have removed the battery. After removing the battery, we are going to insert a dielectric. After removing the battery, we are inserting a dielectric. What will happen now? Capacitance, it does not depend on charge. Okay, it depends on the dimensions. It depends on the medium. So the capacitance will become K times as usual. Okay, capacitance will not depend on whether the battery is connected or not. It does not depend on that. Neither depends how much charge is there. It depends on the geometry of the plates of the capacitor, the dimensions. We are not changing it. Simply we are changing the medium. Okay, so since we are bringing a dielectric constant of K times, capacitance will increase by K times. Now since the battery is removed, charge in the capacitor is not going to change. Why? Battery is not there. So additional charge from where will come? Charge cannot come from anywhere. Neither charge can disappear. The capacitor has become isolated. To the capacitor now, charge cannot come. From the capacitor now, charge cannot escape. So the total charge in the capacitor now will become same as before. So charge on the capacitor will become Q. Now battery is not there. Okay, so potential difference will not remain constant. What will be the potential difference now? So what will be the electric field now? Electric field will become how much now? So first let me find out the potential difference. Potential difference will become how much now? V. V is equal to what? Q by C. Q is Q only. And C is equal to K. C naught. So potential, let me call a new potential to be V res. But new potential will become 1 by K times the original potential. Okay. So therefore electric field is what? V by D. You can do it like this. V res by D. V res. V res is what? V by K into D. And V by D was the previous electric field. So in this situation, in between the two plates, for same charge, okay, when the vacuum is replaced by medium, electric field in the region reduces by K times. Or you can call it, you can do it like this also. E is equal to sigma by epsilon medium. Sigma will be same as before because charge is also same. Or let me take Q only. Q divided by A epsilon M because same charge. We can see Q divided by A K epsilon naught. Q divided by A epsilon naught. Q divided by A epsilon initial electric field divided by K times. So these two situations you remember very, very carefully. With the battery in contact, if we remove the battery, what will happen exactly? Now let me discuss another situations. If we do not fill the entire region by dielectric, but instead if we use a dielectric slab, what is this? A dielectric slab of certain thickness X having dielectric constant K. What is this? Dielectric slab of dielectric constant K and thickness X is placed in between. What will happen to the capacitance now? What will happen to the capacitance now? How to find out capacitance now? Okay, this is a plus plate, this is a minus plate. We have to find capacitance of the system. How to find? For that, you need to understand this is vacuum. This is vacuum. And this particular part is medium. This particular part is medium. So here electric field is E naught. Here electric field is E naught. Here electric field is E. And E is what? E is what? E naught by K. Because here dielectric constant is K. So in this region electric field will get reduced by K times E naught by K. So an electric field of E exists over a distance of X. But from here to here, what is the total distance? Total distance is D. So electric field E exists over a distance of X. And electric field E naught exists over a distance of what is the remaining region? What is the thickness of the remaining region? From total D, you remove X, D minus X. Over this particular length, E naught is there. And over this length X, E is there. Now to find capacitance of the system, we have to find potential difference between the two plates. Okay, so let us find out the potential difference. Potential difference between the two plates, let me call it as V. V will become how much? E naught into D minus X, because electric field, potential difference is what? Electric field into D distance. So electric field E naught exists over a thickness of D minus X, so that is why E naught into D minus X, plus for this particular electric field, what is the potential difference from here to here? Is nothing but electric field into distance, E into X. Think about it. Understanding or not? If you're not understanding, kindly let me know. Okay. So E naught is nothing but Q divided by A epsilon naught D minus X. Okay, and E, electric field E is nothing but Q divided by K A epsilon naught into X. This is potential difference of V volt. Okay, so if we take common from here, Q divided by A epsilon naught, what will remain here? D minus X. What will remain here? X by K. Therefore, capacitance of the system is nothing but Q divided by V. Q divided by V. This will come epsilon naught A divided by D minus X plus X by K. This is the capacitance of the system. New capacitance of the system. You can write it like this also, or you can arrange it like this. Epsilon naught A D minus X 1 minus 1 by K. Like this also you can write. This is the capacitance of the system. Okay. Instead of one slab, now if you put multiple slabs, what will happen if we use more than one slabs? K1, K2. This thickness is suppose your X1. This thickness is suppose your X2. So you can proceed in a similar manner in details, or you can make a shortcut also. I'll show you. First, I'll show you in details. So what will be the total potential difference now? Let me call this electric field is E1. This electric field is E2. And in this region, electric field is E0, E0, and E0. Right? So, electric field E0, it exists over a region D minus X1 minus X2. E1, it exists over a region of, over a thickness of X1. And E2 exists over a region of X2. So if you proceed from here, same thing, Q divided by A epsilon naught D minus X1 minus X2 plus E1 is equal to Q divided by K1 A epsilon naught X1, E2 is equal to Q divided by K2 A epsilon naught X2. From here, if you take common Q by A epsilon naught, how much will come? D minus X1 minus X2 plus X1 by K1 plus X2 by K2. And from here, your capacitance will become Q upon V. How much will become? Epsilon naught A divided by, see how I'm writing, D minus X1 minus X2 plus X1 by K1 plus X2 by K2. Okay, so that means if we put like this n slabs, then capacitance will become epsilon naught A divided by B minus X1 minus X2, let me call it in bracket, plus the plus Xn plus X1 by K2, X2 by K2 plus Xn by Kn plus Xn by Kn. Clear? So this is how we can do it. Summation over epsilon naught A d minus summation over xi plus summation over xi by ki. Done? Now, if this particular dielectric slab, is replaced by a conducting slab, what slab? If this is a conducting slab, replaced by conducting slab, if you replace by conducting slab. So inside a conducting slab, electric field is 0. In this region, electric field E naught. In this region, electric field E naught. So what will be the potential difference now? Potential difference will become E naught d minus x. Let me call this thickness is x. Separation between the two plates is d. Okay, d minus x plus electric field inside is 0. Second part, in this region there is no electric field, so electric field will be in this region only. So second part will become how much? 0. So V is equal to E means E naught means Q divided by A epsilon naught d minus x. Therefore, in this situation, the capacitance will become Q by V, or epsilon A divided by d minus x. So if we replace it by conducting slab, this will be our capacitance. Right? Do it. If we put multiple dielectric constants, for example, we are replacing it by two dielectrics, dielectric constant K1 and K2. From here to area is A by 2, from here separation is D. That means the capacitor we have equally divided into two parts. Upper part we are filling it up with a dielectric, with a material of dielectric medium of dielectric constant K1. The lower part we are filling with a dielectric medium of dielectric constant K2. In this situation, what will be the total equivalent capacitance? In this situation, what will be the total equivalent capacitance? How will you do that? So for this, what we'll do? This is one side is positive, the other side is what? Negative. This side is positive and that side is negative. So we can imagine it to be, this is one capacitor and this is another capacitor whose positive plates are joined and negative plates are joined. So we can assume them to be as if there are two capacitors connected in parallel, something like this. Positive plate of 1, positive plate of 2, negative plate of 1, negative plate of 2, something like this we can visualize. Okay, plus minus, plus minus. Okay, this is suppose C1, this is suppose C2. Then how much will become C1? C1 will become K1 times, why? Dielectric medium is K1. So K1 times, okay, let me again remind you, plate area A, separation D, okay, medium it is vacuum, then capacitance is what? Epsilon of A divided by D, plate area D. If there is a medium, then a K will come, K epsilon of A by D. So instead of K there is K1, epsilon naught, area is how much? A by 2. Plate area of each capacitor will become A by 2. Separation is how much? Same, D. So this will become K1 epsilon naught A divided by twice D. Similarly, C2 will become K2 epsilon naught A divided by twice D. Since they are connected in parallel, therefore equivalent capacitance will become how much? C1 plus C2. So what will be taken common? Epsilon naught A divided by twice D is common. Within bracket how much will remain? K1 plus K2. This is what happens in this type of situation. If the dielectrics are placed like this, then K1, K2. Let me divide the space into two equal parts. Plus minus plate area as usual. इन सिचुएशन में, इन दिस सिचुएशन क्या बोलेंगे? How they are connected? In this situation, we are going from this is positive plate to negative plate, going from one, the first capacitor, then the next capacitor. So we'll assume as if there are two capacitors connected in first capacitor, then the next capacitor. Okay. From here to here, we'll assume to be one capacitor. From here to here, we'll assume to be another capacitor. Okay. First capacitor, second capacitor. This is C1, this is C2 connected in series. How much is C1? K1 epsilon naught. Area is like before. Area is complete area, A only. But separation has reduced to, okay, half. D by 2. D by 2. Okay. This can be written as twice K1 epsilon naught A divided by. Similarly, C2 become how much? Twice K2 epsilon naught A divided by D. Since they are connected in parallel, therefore equivalent capacitance will become how much? C1 into C2 divided by C1 plus C2. Let us do directly. C1. This is C1. Twice K1 epsilon naught A divided by D into C2 twice K2 epsilon naught A divided by D divided by C1 plus C2. C1 plus C2, if we do, what is common? Twice epsilon naught A divided by D is common. Twice epsilon naught A divided by D. D common. Within bracket, what will remain? K1 plus K2. This is C1 plus C2. So out of this, you see epsilon naught A divided by D. Epsilon naught A divided by D is getting cancelled out. Okay. And this 2 is also getting cancels out. In the numerator, what has remained? K1 twice K1 K2. In the numerator, what has remained? Twice K1 K2 divided by, what is in the denominator? K1 plus K2. K1 plus K2. And what has remained here? Epsilon naught A divided by epsilon naught A divided by D. This will become the capacitance in this connection. Similarly, if you replace the medium in between, if we use, instead of 2, if we use 3 dielectrics like this, this is K1, this is K2, this is K3. Okay, let me take the separation D by 2. Actually, see, to make you understand the calculations, or to make you understand the concept, I'm just using the separations equal. You can take different separation also. One is X, the other is D minus X. I'll be showing one problem on that. D by 2. And let me call a plate area is A by 2. Plate area is A by 2. This separation is D. So in this situation, you can see there are 3 capacitors. 1, 2, 3. These 2 capacitors, they are connected in series, and both will be in parallel with the third capacitor. How we can visualize it? Okay, positive plate of 1 is connected to the positive plate of 3, and negative plate of 2 is connected to the negative plate of 3. So in between there will be negative and positive. Negative of 1 is connected to the positive of, okay, 2. Okay, in between dielectric is there. So since dielectric is there, polarization will be there. Okay, as a result of polarization, everywhere the molecules will be, polar molecules will become like this, plus minus everywhere. Okay, like this. So if I divide it here, one side positive, the other side negative, we can assume. Okay, so this will become like this. The first capacitor, positive plate, negative plate, then negative of first is connected to the positive of second, and this is the negative of 2. They are connected to the positive of 1 is connected to the positive of 3, the third one, and negative of 2 is connected to the negative of 3. So between these 2 points, these 2 are in series, then in parallel with the third. 2 are in series, then in parallel with the third. So how much will become C1? C1 is nothing but K1 epsilon naught A by 2 D by 2. Plate area A by 2. Plate area A by 2. And separation is D by 2. So that is why 2 cancels. This is K1 epsilon naught A by D. Similarly, second capacitor also will become K2 epsilon naught A divided by D. And the third capacitor, C3, how much will become?